All right, so this is reteaching graphing quadratic functions. And in reality, this is a review of sections 4.1 and 4.2. So hopefully we review how to graph quadratic functions, and then at the end, you're going to be given a worksheet to work on, and I'm going to grade the evens, and you're going to work on the odd problems. So quick review of vocabulary. A quadratic function is a function that can be written in standard form. So we have y equals ax squared plus bx plus c. Notice you have the quadratic term here. You have the linear term, and you have a constant term. The only thing that can't be 0 is a for a quadratic function, because otherwise the ax squared term would go away. So the graph of a quadratic function is called a parabola. It's a U-shaped graph of the quadratic function. Okay? The vertex of the parabola is either the lowest point if it opens up or the highest point if it opens down. The vertical line passing through the vertex of the parabola, which divides the parabola into symmetrical parts that are mirror images of one another, is called the axis of symmetry. All right, so first quick review, we have the 5 steps that I recommend doing. If you are given a quadratic function written in standard form, so it looks like this, then you follow these 5 steps. Step 1, you're going to find the direction of opening. Step 2, you're going to find the y-intercept. Step 3, you're going to find the axis of symmetry. Step 4, you're going to find the vertex. And in step 5, you're going to graph the parabola. All right. So example 1. Here is a function, y equals x squared minus 4x plus 3. And if you notice, it's written in the form of y equals ax squared plus bx plus c. And if it helps you, you can identify these coefficients. A is 1, b is -4, and c is +3. All right, so step 1. This is going to open up because a is positive. Step 2, the y-intercept is going to be the point 0, c, which in this case is 3. And then for step 3, we're going to do a little bit of math. We need to find the axis of symmetry. So we're going to use the formula x equals the opposite of b over 2a. So plug that in, opposite of -4 over 2 times 1. So we get 4 over 2 when we get 2. So the axis of symmetry is x equals 2. It's the equation x equals 2. And in step 4, we find the vertex by plugging that point into our function. So y equals 2 squared minus 4 times 2 plus 3. So we get 4 minus 8 plus 3. That's going to give us -1. So our vertex is at the point 2, -1. All right, what we're going to do now is plot these points. So step 1 is to plot the vertex at 2, -1. Then our axis of symmetry, which is at x equals 2. And then our y-intercept, which is at 0, 3. Now we can use symmetry and plot my another point, because remember the same number of units from the axis of symmetry. And then we can connect the dots with the u. And there is your parabola. Okay. So if your quadratic function is written in the form y equals a times x minus h quantity squared plus k, this is called vertex form. And you're going to have these 5 steps. So step 1, you're still going to find the direction of opening. And step 2, you're now going to find the vertex. And the vertex is written in the formula. Then you find the axis of symmetry. And then you find any other point you want. The y-intercept is usually an easy point to find. And then we're going to graph. So example 2, step 1, direction of opening. So we know this opens up because a is positive. Step 2, the vertex is in the equation, opposite in sides and same outside. So 3, -4. All right, step 3, the axis of symmetry is x equals 3. It's always going to be this x coordinate. And then step 4, let's find the y-intercept. You could pick any other point you want, but usually the y-intercept is easy. So we plug that in, y equals 2 times 0 minus 3 squared minus 4. So we have y equals 18 minus 4, which equals 14. Okay. So the y-intercept is 0, 14. So it's a big number. All right, so our vertex is at 3, -4, which is approximately right there. There's my axis of symmetry. And then my y-intercept is at 0, 14, which is all the way up here. And then I can plot the other point over here and then connect the dots. Now, if this is a little weird, you could pick other points. So you could have substituted in 1 or 2 and then found another point on this parabola. All right, and then our last one is if it's written in intercept form. Okay, so again, we're going to find the direction of opening. Then we're going to find the x-intercepts. X-intercepts are P and Q. They're right in the formula. Then you find the axis of symmetry by taking the average of your P and Q. And then you find your vertex by plugging that back into your equation. Okay. So example 3. So step 1, we know this opens up because A is positive. All right, step 2, x-intercepts. And that's going to be at the point 3, 0, and the point -8, 0. So they're directly from here. So that tells you P is 3 and Q is -8. Step 3, we find the axis of symmetry. So x equals P plus Q over 2, 3 plus -8 over 2. So we get -5 over 2. So your axis of symmetry is x equals -5/2, or -2.5. And then step 4, you find the vertex. So we're going to substitute that back in. So we have y equals 2 times -5/2 minus 3 times -5/2 plus 8. So we have 2 times. This is going to be -5.5. And this is going to be positive 5.5, I think. All right. Then we're going to multiply these together. So I'm just going to do some math here. So we have 2 times. I'm going to convert this to 11/2, so -11/2 times 11/2. And that's going to give me -121 over 2, which is equal to -60.5. I think that's right. Okay. All right, so step 1, we find 3, 0. Here's 3, 0. And then we find -8, 0, all the way out here. Okay. And then our vertex is way down here, -2.5, all the way down there. And there's our axis of symmetry. Connect the dots. And there you go. So this is supposed to be right down here at -60.5. Now, that is it. You're now going to work on the Graphing Quadratics worksheet. Okay, you have answers to the odds. So I want you to check your work as you go. Okay, Dr. Nichols is going to grade the evens. Okay.